Copyright in these lectures is either owned by the ANU or a third party who has licensed the ANU to use it. Students may use the recording for personal study only. No lecture may be communicated online, copied or shared without the prior permission of the ANU.
Okay, well, make a start. Just a reminder, you have a quiz this week. Okay, so the quiz is on valuing forward contracts, like I told you last week, thank you. On valuing forward contracts, you'll cover the material in your tutorial, and then you'll have a quiz in the last 10 minutes or so of the tutorial. It's your responsibility to make sure you bring along a calculator, a pen, everything like that. If you don't have one, it'll be very hard to do the quiz if you don't have a calculator, so please make sure you bring a calculator. Reminder, you're allowed no notes, anything like that. You clear your desk and you have a pen and calculator on your desk, and that's it. The person sitting next to you will have a different quiz to you. Okay, so if you copy off them, it'll be very clear that you've copied. Okay, because you'll be copying down potentially a correct answer, but to the wrong question. Okay, so it'll be very obvious for us. What does that lead to? That leads to a 0 for the quiz, obviously, but also leads to an investigation under academic integrity. Okay, so please make sure you do your own work. Don't copy off anyone else. Okay, you also have a quiz next week, and I'll talk about what that quiz will be on as we go through the lecture today. Okay, so today's lecture is on interest rate contracts. Thank you. Thank you. Is on interest rate contracts and swaps. Okay, so we're going to be talking about different types of interest rates that we can use and we will use in this course, and we'll also talk about swaps. Okay, and what swaps are used for. Okay, and they're all about changing the nature of an investment or a liability. Okay, so you might be exposed to a type of risk, maybe a floating rate or variable rate risk, and you want to swap it to be exposed to fixed. Okay, so where interest rates don't change. And swaps can allow you, thank you, and swaps can allow you to do that, and we'll cover that today as well. We'll also talk about how we value swaps, and we'll also cover various different types of mechanisms for using swaps as well. Okay, so we're going to start off by talking about the different types of interest rates. So in this course so far, what you've covered, and from Foundations of Finance, is essentially you're given an interest rate. And you've been told in Foundations of Finance it's either a nominal interest rate, it's a periodic interest rate, or it's a effective interest rate. And then last week we introduced this idea of having continuously compounded interest rates. So today we're going to talk about the different other types of rates. So we're going to talk about things called repo rates. We're going to talk about things called LIBOR, okay, which are commonly used in finance. Okay, so a lot of you, well, some of you, may have heard about this LIBOR rate, the London Interbank Office Rate. Okay, and it's a proxy, if you like, for what the variable rate of interest is. Okay, so the interest rate that changes on a daily basis. And it's been in the news in the last few years because we found during the financial crisis, a lot of banks in the US and the UK actually colluded with each other to set this variable interest rate. So the way it's meant to work is this London Interbank Office Rate is a variable interest rate, and to find out what that variable interest rate is, every day there's a poll of all the banks, and they say, what are you charging to lend to banks on the overnight market? So essentially, at the end of the day, you loan some money and you expect it to be paid back the following day. What rate are you quoting? And then all the banks give this information, and then we get an average, and this is what's called the variable overnight interest rate. So during the financial crisis, and they're not meant to tell the other banks what they're charging. So what happened during the financial crisis is that a number of banks got together and they actually colluded and agreed in advance what the overnight interest rate they would charge would be. Now, the effect of this was that they actually had lower interest rates. They actually kept interest rates lower than they otherwise would have been. So it actually had a good effect on the economy. It actually stimulated the economy because there were lower interest rates than they would normally charge, but they're not allowed to collude, okay, with each other. So people got charged and there were fines that were handed out as well. We had something a little similar in Australia as well in terms of collusion about what banks would charge each other. Okay, so we know what interest is. You have your borrowers and you have your lenders, and it's all about the rate of return you demand. Okay, so if I'm going to lend someone money, I demand a return on that. I want the principal, so the amount I've loaned back, but I also want some sort of interest, okay, a return on my investment. And that's why it's really important to think about this idea of credit risk. Okay, so this gentleman down here might have a really good credit history. Okay, he has a mortgage, he's had a credit card, he's serviced it for a number of years. Okay, so he has a good credit history, so if I lend him money, I might charge him whatever the standard rate is, the risk-free rate, plus maybe just a couple of percent, because he's got a good credit history. Okay, I'm highly certain that he will pay me back that money. So I charge him a lower interest rate. He's good credit. Okay, and then fortunately over here, we have another borrower who has no credit history at all. Okay, I have no idea her likelihood to pay me back the amount of money will be. So I charge her in a higher interest because she is riskier. Okay, a riskier person for me to lend my money to. Okay, so that's the bottom point there. The higher the credit risk, the higher the interest rate that is charged. And that makes sense. Foundations in finance, you learned about risk and return. The higher the risk, the more return you demand. So when you loan someone money, the more riskier they are, in other words, the less likely they are to pay you back the money, the higher the interest rate you will charge them. So then in terms of the next few rates we're going to talk about, we talk about treasury rates. So you can open up the Financial Review, you can get online and you can have a look at what certain treasury rates are for Australia, the US, different countries in the world. Okay, and this is the rate, right, that is set, if you like, by treasury departments in terms of interest rates on money they borrow. Okay, so governments borrow. And we normally assume that this is riskless. Okay, because we assume that governments are going to pay back the money, okay, that they borrow. Okay, so they're backed, if you like, by some sort of sovereign wealth. Okay, likely the government will pay it back. So sovereign risk, if you like, is the chance that a government may not be able to pay back its debts. Okay, so Australia has never defaulted on any of its loans. Okay, so that's fair enough for a country like Australia to think of the treasury rate as a risk-free rate. Okay, but if you go to other countries, okay, so we could think of Argentina, we could even think of Russia, right? These are countries that have defaulted, right? So you wouldn't say that their treasury rates are necessarily risk-free rates. And then you've got countries like the US, right? So in the 1800s, the US did default a number of times on its outstanding debt. Okay, and we have periodically the US government shut down because they can't agree on a budget. Okay, and that leads to some concern that maybe the US can't meet its debt repayments. Okay, but it has so far under this presidency. Okay, so the LIBOR, that's the rate I was talking about at the beginning of the lecture. That's that variable overnight interest rate. So it stands for the London Interbank Offered Rate. So you quote the banks, you find out how much are you charging, okay, to loan money to other banks. They take a poll, they average it out, and that gives us some sort of proxy for what the an overnight or a certain period of time interest rate might be. Okay, a repo rate, less commonly used nowadays, but this is kind of like a repurchase agreement. Okay, so you can back out what the interest rate might be. So essentially you sell an asset to someone else, that's kind of like your collateral, and then you agree to buy it back at a later date for a certain price. And out of that you can back out what's the difference between the amount you received, the amount you pay back, to work out what the interest rate would be, okay, on that particular agreement. But repo rates are less used today than they used to be in the past. Okay, zero rates. So zero rates are like zero coupon bonds. You have an initial selling of a bond, and then you agree to pay back its face value at the end. So just like in foundations of finance, to work out the bond price, you just found the present value of the face value of the bond. Okay, so what you can do is, if you look at what they're trading for on the market, thanks guys, in the middle there. Thank you guys. Okay, so you can look at what these Thank you. So you can look at what these bonds are trading for. Okay, so you can see them actually trading on the stock exchange. You can look at their face value and you can back out what the interest rate is. Okay, so what the zero interest rate would be. Okay, so we've got an example here. Okay, a zero coupon rate of an investment starts today and lasts for N years. All of the interest and principal is realised at the end, so no coupons are paid. It's a zero coupon bond. For example, suppose that 1 million is invested for 5 years with a 5-year zero rate with continuous compounding of 7% per annum. Okay, so what would that be worth at the end? It's very simply just the $1 million you've invested multiplied by e to the power of the continuously compounded 7% times 5 years to give you $1.42 million at the end. Okay, so that just tells us what is a zero interest rate out in the market, and then you can use that as an interest rate that you might be investing at. Okay, and then we have the coupon paying bonds. Okay, so what's the convention for how often coupons are paid? Every 6 months. Okay, so the convention is coupons are paid every 6 months. So if you get a question in an exam where it doesn't tell you how often they're paid, assume it's every 6 months. If I tell you they're paid quarterly, then obviously you assume they're paid quarterly. And all those same other conventions from foundations of finance remain as well. So if it's quoted at 8% per annum, the coupon rate, and they're paid semi-annually, then you're just going to divide that 8% by 2. If they're paid quarterly, you'll just take that 8% and divide it by 4. So you don't need to do any other conversions, okay, with the coupon rate. You assume it's compounded as frequently as the coupons are paid. So you just have to straight divide by the number of times the coupons are paid in a year. But in discounting back the cash flows, you still have to discount them back at the continuously compounded rate. So if we have a quick look, okay, so bond pricing. So with our zero coupon bonds, to work out the value of a zero coupon bond, you just take the face value of the bond and then you multiply it by e to the power of negative RT, where F equals my face value of the bond. R must be, again, my continuously compounded rate. So if it's not compounded continuously, you need to do what we did last week to convert it to a continuously compounded rate. And my t is going to be, or my time is going to be expressed as a fraction of a year. And then my coupon paying bonds. So in terms of the example you have in your lecture note, you're told that coupons are 8% per annum, and then just like in foundations of finance, to work out the value of the coupons, it's my face value of the coupons divided by the number of times coupons are paid in a year, multiplied by my coupon rate. So in the question in your lecture notes, you're told the face value of the bond is $1 million. Coupons are paid twice a year, and your coupon rate is 8%. So that gives you the $40,000 in terms of the value of each coupon. And then if you were to draw a timeline, this bond has a life of 2 years. So the first coupon's paid here, second coupon here, third coupon here, and then remember at the end of the life of the bond, you get the final coupon of $40,000, plus you also get the face value of the bond of $1 million. Is this okay with everyone? This is just straight from Foundations of Finance. Okay, nothing new. And then, so if you look at that example in your lecture notes, the other thing we have to do is when we discount the cash flows back, remember we have to match the interest rate with the time period. So if you're going to bring your cash flows back 6 months, you've got to use the 6-month rate. 1 year, you use the 1-year rate, and so on. So no longer are interest rates fixed for the whole period of time. They could be, but in this particular example, they're not. Interest rates fluctuate through time. So when you work out the value of this bond, that first $40,000 gets discounted back at 6 months. So e to the power of -0.5 times the interest rate of 6%, and then so on. Now it's 6.2% back a year, 6.3% back 1.5 years, and finally 6.2% back at 2 years. Okay, which gives us $1,031,000. So the problem here, though, is that you can't use that formula used in Foundations of Finance. Okay, you remember you used your present value annuity formula, right? Because you've got repetitive cash flows of $40,000. Well, because the interest rates don't remain constant, you can't use that present value annuity formula anymore. You've got to discount back each individual coupon at its relevant interest rate. Which means my promise to you is if I was to set you a question on finding the value of a bond, I'm not going to have any more than, say, 8 cash flows. Okay, because if I had a 20-year bond, 40 cash flows, you're going to make a mistake. You'd spend half an hour on the question and get it wrong, right? Because you're entering all that stuff in your calculator. Okay, so if I ask you to value a bond, they're only going to have a life of 2 or 3 years. Okay, otherwise there's too many cash flows to do. Any questions with bond pricing? Okay, pretty similar to what you did in Foundations of Finance. All we've introduced now is this idea of you've got to discount the cash flows back at their correct interest rate, and you've got to use the continuous compounding formula. And no longer can you use the present value annuity formula because interest rates change through time. Okay, par yield. So par yield is a coupon rate, okay, that causes the bond price to be equal to its face value. Okay, so if it's selling at par value, that means it's just selling for whatever the face value of the bond is. Now let's imagine that we need to try, and I'll do the calculation on overhead here. So in a finance degree, we say, you know, having a maths background is good, but it's not required. Okay, it's not a prerequisite. So the new maths today, it won't be new for some of you. For some of it, you will be new. I will teach you how to do the maths for this today in an overhead. Okay, but essentially what we have here is we have a bond, and we're told that it's currently selling for $1.1 million. So that is the value of the bond. We're told what the coupons are. We're told the coupon rate, it's 10% per annum. So that means each coupon's worth $50,000. They're paid twice a year. And then you're given a half a year, well, you're told that for the next 1.5 years, interest rates remain flat or constant at 0.5%. But then you don't know what the 2-year interest rate is. So what you have to do is you have to back out and solve for what the 2-year interest rate will be. Okay, so that's what we're going to do on an overhead now. So again, you see these prices quoted in the stock market. Why you do this? What's the point? To try and find out what interest rates are, what the actual interest rates in the market are, and what you can get access to. Okay, and unfortunately, you kind of have to back this stuff out. They're not necessarily listed for you. Okay, so in this question, remember we are told that the coupon rate is 10% per annum. Okay, so the values of the coupons are going to be, the face value of the bond is $1 million, you're told. Paid twice a year, coupon rate of 10%. So each coupon is worth $50,000. So to work out the value of the bond, well, we know the value of the bond, I should say. It's the value of my bond is equal to $1,100,000, but that must be equal to the present value of the face value of the bond plus the present value of all of the coupons. So that gives me 50,000 times e to the power of negative 0.05 times a half. Remember, interest rates are fixed at 5% for 1.5 years, so you know them for sure. Plus the next coupon of 50,000 times e to the power of negative 0.05 times 1 year. Then the third coupon of 50,000 times e to the power of negative 0.05 times 1.5 years. Plus, now at the very end, you get the face value of the bond of $1 million, plus you get the final coupon of 50,000. So in all, you get $1,050,000. Yep, the 1 million face value plus the final 50,000 coupon. And the present value of that is e to the power of negative r. We don't know what that interest rate is. That's what we're solving for, times 2. And all of that equals $1,100,000. Okay, so what I'm going to do is I'm going to plug these into my calculator, okay, and solve for them. So I end up with 48,765.4956 plus, so that's that one. Then I have 47,561.4712 plus the third 50,000. That's going to be equal to $46,387.17432 plus 1,050,000 times e to the power of negative r times 2 equals 1,100,000. So what do? I need to have my unknowns on one side and everything else on the other side. So essentially what I'm going to do is, this junk here, I'm going to subtract that from both sides. Okay, so I subtract from both sides. So that gives me, on the left-hand side now, 1,050,000 times e to the power of negative r times 2 is equal to 1.1 million minus this junk over here, which gives me 957,285.8589. Then what do? Someone, what do? Just one person out loud, what do? I divide. Is that right? Yes. I'm going to divide both sides by 1,050,000. Okay, that's going to give me this by itself. Okay, so that gives me e to the power of negative r times 2 is equal to 0.911700818. Okay, so there's a rule, it's called a log rule, that if you take the natural log, so ln, of both sides, that enables you to bring that down the front. Okay, so enables you to bring the power down the front. So what we do is we take the natural log of both sides. So some of you would have done this before, others won't have. So that means that the natural log of e to the power of negative r times 2 is equal to the natural log of 0.911700818. So as long as you do the same thing to both sides, okay, you haven't changed anything. Divide both sides by the 1,050,000. You take the natural log of both sides, you're doing the same thing. But taking the natural log of this enables me to bring that down the front. So that gives me negative r times 2, or negative 2r. Now what's the natural log of e? 1. Okay, so the natural log of e is just 1. So that's nice. And then on the right-hand side, that gives me negative 0.092443393. You'll notice I'm keeping all the decimal points. And then what do? I divide both sides by negative 2. Dividing both sides by -2 gives me r by itself. And that gives me r is equal to approximately 4.6%. Okay, so you've backed out the 2-year interest rate. So interest rates remain constant at 5%. Yep, 5% for the first 1.5 years, and then the 2-year rate, it drops to 4.6%. Okay, and you've backed that out. You've worked that out in this particular question. Any queries there? Everyone's okay with that? Okay. Okay, so forward rates. So we can use forward, and so a forward rate is not a forward contract, okay? It's called a forward rate, but it's not the same as a forward contract. So we can use forwards and futures contracts to lock in interest rates. Right? You take a long or short position at a certain interest rate, okay, or on a certain bond, maybe a bank accepted bill. Okay, and you can use that to lock in rates. You can also actually play around in the spot market to lock in interest rates as well. So here the example might be that I need to borrow some money in a year's time. Not today, but in a year's time. My concern is that interest rates will go up between now and a year from now. So I can use forward rates to actually lock in an interest rate today. Okay, lock in an interest rate by actually trading in the spot market at the moment, the spot interest rate market. So we'll do this on an overhead. So in this particular question, we're told that a company, so this is the exact same question that's in your lecture notes, a company needs $104,000 in 1 year's time, and they will borrow that money for 1 year. Okay, so they'll borrow the money for 1 year. So the first time we do this, we're going to use simple discrete interest rates. We'll convert it to continuous compounding in a few minutes. So the best thing to do is to draw a timeline. So 1 year from today is when you want the $104,000. Your concern is what's going to happen to interest rates between now and then. And then in 2 years from now, because you want to borrow this money for a period of 1 year, you'll pay it back 2 years from now. You get the money 1 year from now, pay it back a year later, which is 2 years from today. So at time period 2, you repay the, let's say, repay the loan. So let's imagine there's no forward or futures contracts out on the market to allow you to lock in the interest rate from year 1 to 2. But what you can see in the marketplace is if you borrowed money today or invested money today, here's the 1 year rate and here is the 2 year interest rate. So you can observe today how much you would be charged or earn for lending or borrowing for 1 year or for 2 years from today. And the 1 year interest rate is equal to 4%, and the 2 year interest rate is equal to 5%. So what you do is, to set this up, to lock in the interest rate, because today you can lock in 4% and you can lock in 5%, you borrow money for 2 years today. Okay, so today you borrow money for 2 years, but you don't need the money today. So what do you do with that money you borrow today? You invest it. So you borrow the money for 2 years, and then you invest it for 1 year, because you need the money in 1 year's time. So the cash flows are, you borrow the money on that day there, right? So we borrow for 2 years, and then we invest it, that money we've borrowed, for 1 year. And that's the day we actually need the money. But we've locked in the 1 year and 2 year rate today, so we know with certainty what interest rate will be charged. So if we assume just simple interest, if you want $104,000 in a year's time at an interest rate of 4%, how much would you have to borrow today if you're going to invest it at 4%? How much would you borrow today? $100,000. Right? If you borrow $100,000 today, in a year's time you'll have $100,000 plus 4 years interest. You'll have your $104,000. Okay, so step one in this strategy is I borrow money for 2 years at 5%, and the money I have borrowed, you invest for 1 year at 4%. So as we just said, how much money do I borrow today? Well, I want $104,000 in 1 year's time. So that's going to be the same as $100,000 today. Because $100,000 multiplied by 1 plus 4% to the power of 1 gives me $104,000. Okay, so I borrow $104,000 today. Any questions? Yes? Yeah, so for this first example, I'm using discrete just to make it easy for us. Okay, in 4 minutes' time, we're going to do continuous. Okay, but if I start off with continuous, okay, it can get a little bit tricky, so I just want to make it nice and simple to start off with, and then we'll convert it to continuous. In fact, we're just going to use a continuous formula. We won't even go through this stuff, but I just want to make sure you understand the cash flows, what's happening. So I borrow $100,000 today, so of course the next question is, how much do I pay back? Well, I borrowed $100,000, and I borrowed that at an interest rate of 5%. And I borrowed the money for 2 years. So I'm going to have to pay back $110,250. Everyone okay with those cash flows? Borrowed $100,000 because I wanted $104,000 in 1 year's time. But that $100,000 I borrowed, I have to pay back $110,250 2 years from today. So then the question is, what interest rate does that imply that I have locked in between year 1 and 2? Remember, that's all this is about. What interest rate have I locked in between years 1 and 2 by doing these calculations? Okay, and I've locked it in, it's fixed for me. There's no risk whatsoever. Well, I could do it a couple of ways. I could say at the end of year 2, I have to pay back $110,250, and at the end of year 1, I have $104,000, right? That 100 grand has grown to $104,000. And that gives me 6.01% interest that I've locked in. Or I could say 1 plus the 5%, and I've got to pay that for 2 years, divided by the 4% that I invested for 1 year, and that also gives me 6.01%. Okay, this is with discrete simple interest. Hopefully the numbers are simple enough that you can kind of understand what's going on. You want to lock in that interest rate between years 1 and 2. There's no forward or futures contract that allows you to do it, so instead you use the spot interest rates. So I borrow money for 2 years. I want to pay back in 2 years, so I borrow it for 2 years. I invest that money for 1 year. That's when I need the money, and that allows me to lock in the money I need in 1 year's time, and I pay it back 1 year later at the end of year 2. So the question we had before is, what about continuously compounded rates? That's what this course is all about. Well, the nice thing is it's even simpler with my continuously compounded rates. Okay, so the formula for working out the forward rate with continuously compounded is equal to essentially the rate times the number of years, where this rate here is going to be the longer time period interest rate. Okay, so if you want to lock in the rate between years 3 and 4, it's the longer time rate, so the 4-year rate. And this rate is going to be the shorter period. And this is the longer period, and this is the shorter period. So in your lecture notes, let's go to those. You're a corporation, and you've looked at your forecasting and you realise that in 3 years' time you're going to need to borrow some money. And you're going to borrow it for a period of 1 year. The risk you face is interest rates will go up between now and 3 years' time. There's no forward or futures contracts that can allow you to lock in the interest rate, but you do see 3 and 4 year interest rates. Okay, so what are you going to borrow at? What interest rate? The 4 or 3 year interest rate? You borrow for the longer time period, right? You're going to borrow for 4 years, and then when do you need the money? In 3 years' time, so you invest that money for 3 years. So what we're trying to work out in this question is, using these spot rates, what interest rate can I lock in for the interest between years 3 and 4? Okay, what's the interest rate going to be between years 3 and 4? And I just use this formula here. So again, I start off with the longer time period, which is the 4-year interest rate, which is going to be 11%. I'll just write it down. How long is that time period? Multiply it by 4, easy. Minus the 3-year, the shorter time period, which was 10.8%, and that was invested for 3 years. It was a 3-year rate. And then I'm just looking at the difference between the 4 and 3 year rate, so 4 minus 3. And simply that gives me 11.6%. Okay, so it's a really easy formula to remember. Just the longer time period minus the shorter time period always. Any questions? Okay. So again, these are things you need to be thinking about, right? For when you work one day you may work in a corporation. There's all sorts of different ways you can manage risk. Okay, so you've done foundations of finance and you've sat there and you've thought, right, all I've got is forwards, futures and options contracts. Wrong, there's lots of things you can do. First of all, you do an analysis, do I even need to hedge this risk? Right? What is the market expectation about what's happening to prices? If the market expectation here is that interest rates are going to go down, would you hedge the risk? Okay, so this is the extra bit, right? So what I can teach you in this course is how you calculate all of these things. And then we need to have another conversation is about what do you actually do when you get a job. Okay, so your boss calls you in and they say to you, right, you're working at Qantas. And they say to you, 40% of our bill every year is aviation fuel. That's 40% of our costs. Should I be worried about it next year? And you go, how about we use some forward contracts? They'll kick you out. Right? You haven't given them any information. Right? What they want to know from you is a detailed analysis of what's going to happen to aviation, or if you like, to oil prices. If you sit there and go, you know, I've done my research here, and the forecast is that oil prices are going to go up by 25% over the next year. Therefore, I recommend you use forward contracts to lock in the rate today. Why do I say that? Well, they're not going to cost us anything, okay, unlike options. And I'm 90% certain that oil prices are going to go up. They go, thank you. Or you walk in there and you go, look, this is a difficult one. I've looked at the consensus forecasts, and 40% of the people out there are saying oil prices will be 30% lower next year. 30% are saying they're going to be 10% higher, and the remainder say they're going to be about the same. And you could have two recommendations there. One of them might be, look, I think there's a high likelihood they're going to stay the same or go down, so let's do nothing. Or it might be, you know what, there's a risk they might go up a little bit, but I'm not certain. Let's not lock ourselves in with forwards or futures contracts where we can't take advantage of movement of prices going down, but let's hedge maybe 20% of our fuel bill with options. Okay, it's going to be cheaper because we're only going to hedge 20%. Okay, but if something does go bad and prices go up, at least we've got some protection in place. Okay, so you've thought about it, you've done some research, you've done some analysis. And then the problem is, 6 months later, if you're wrong, you get fired. Right? But at least you've gone in there with a recommendation you've thought about. Right? So this is not just about how do I plug things into an equation, how do I plug things into a formula. Okay, when you're in the workplace, you really have to be thinking about what recommendation you provide, and it has to be backed up with research. Okay, it really has to be backed up with work you've done in investigating what's going to happen to your company. Okay, so that's the value add, if you like, of an employee. Right? Anyone out there can use a computer to decide which forward, futures, or option contracts to use. Your value add is the recommendation about do you even need them or not. Right? Because a year later, when your options cost, let's imagine for Qantas, $30 million. Right, it's not a lot in the scheme of things, but it's still $30 million. And the oil price plummeted. Right, can you justify why you made that recommendation? Right, what research did you use to back that up? Of course, no one can forecast some, tragic event happening, something out of the blue. Okay, huge explosion and war in the Middle East affecting oil prices. Okay, you can't predict that, but you should be looking at what you can predict. What is usage like in the world? Okay, thinking about in the next 30 years, right, there's going to be an extra 5 billion people traveling in planes. Okay, most of them in our region, the Asia-Pacific region. Okay, so the big problem facing airline companies at the moment are A, number of planes, and B, pilots. Right, now, you probably can't do anything about the pilots, but you could do something about the cost of planes, right, managing that risk. Okay, so these are good, forward rate agreements. And this is all you need to know about forward rate agreements. You're not going to have to value forward rate agreements, anything like that. They're not really used that much anymore. So I'm just going to do an example here, and that's all you need to know. So this gentleman over here, he wants to buy a car, right, at the end of the year. Risk he faces is, he needs to borrow the money to buy the car. The risk obviously he faces are that interest rates are going to go up. So he could use forwards, futures, options contracts. He could use the forward rates we just calculated, or he could lock in a forward rate agreement. The way a forward rate agreement is, he goes up to an organisation, imagine it's me, I'm a bank out there, and we come to an agreement. And that agreement is, I guarantee the interest rate he'll have to pay is 8%. So we've got an agreement that the interest rate he'll have to pay on his loan will be 8%. Now it's a year later, and he wants to buy his car, and he has to borrow the money. Now he doesn't borrow it from me. All I've done is guaranteed that interest rate. Instead, he borrows it off this bank over here. And because of how interest rates have moved, interest rates are now 10%. So the way the forward rate agreement will work is he will pay this bank the 8% that he had agreed with me, and the missing 2%, I pay the bank. Okay, so I pay him that extra amount. Either way, he's locked in his 8% interest rate, and I pay the extra bit. Or imagine the reverse is true. It's now a year later, interest rates have dropped. He goes to a bank and says, I'd like to borrow money, and they say, sure, interest rates are 5%. Unfortunately, he can't take advantage of that. He pays the bank 5%, and he pays me the other 3%. Either way, he's locked in his interest rate of 8%. And all I've done is I've made sure that that 8% does occur. So either I pay the higher amount, or the difference, if the interest rates go up, or he pays me the difference if interest rates go down. Okay, but I've locked that in with this forward rate agreement. Okay, and that's all you need to know. Okay, you don't need to worry about valuing them. They're not used that much anymore, but still something important to know. Okay, so before we have a break, let's just introduce interest rate swaps. So interest rate swaps are about changing the nature of an investment or a liability, like I said at the beginning of the lecture. So you might be exposed to fixed interest rates, but instead you want to be exposed to variable interest rates. So what you can use with a swap is you can have two parties who come together. They enter into an interest rate swap where, this woman down the front, let's imagine she wants variable and I want fixed. The way the interest rate will work, even though I want fixed, I borrow at variable, and even though she wants variable, she borrows at fixed. So we're borrowing at the opposite of what we want, but then we swap the cash flows between each other. And by swapping the cash flows between each other, we actually both end up with a better interest rate than what we could get on our own. So in other words, this is about absolute and, well, really it's about comparative advantage. Okay, so you've all done some economics. You all know what comparative advantage is. Okay, so even though I wanted, what did I want? Fixed, I think. Even though I wanted fixed, my comparative advantage lies in variable. So it makes sense for me to work in the variable space, a bit like in economics. Okay, so I borrow at the variable. Even though she wants variable, her comparative advantage lies in fixed. So it makes sense for her to work in the fixed market. But then we swap the cash flows so that she ends up with variable, I end up with fixed, and we're both better off, okay, by doing what we call an interest rate swap. Normally banks set these up, and of course they make some money out of it. Okay, they take a cut, a percentage off it. Okay, and so again, we change our exposure and we reduce the costs of borrowing. Okay, this is a good place to have a break, so we'll have a break now and come back in 6 minutes at 12 o'clock. Any questions, please come down and ask me. Okay, so in this question, so we're going to do an example of, thank you. Thank you. Thank you. Okay, so let's have a look at an interest rate swap example. Okay, so company A can borrow at a fixed rate of 7% and a floating rate of LIBOR plus 1%. What does that mean? That just means the LIBOR is, thank you, LIBOR is just whatever the, thank you. LIBOR is just whatever the floating rate is, okay? It doesn't matter. It could be 4%, could be 4.8%. It changes on a daily basis. Okay, so we just represent it by saying LIBOR. Okay, it just represents whatever that floating number is, but they pay 1% higher than whatever that floating rate is. So they pay a premium of plus 1%. Then we have company B, and they can borrow at a fixed rate of 10% and a floating rate of LIBOR plus 2%. Okay, but they really want a fixed interest rate. Okay, so you can see that company A has what we would call the absolute advantage. It must have a lower credit risk. It can borrow at a lower fixed rate and a lower floating or variable interest rate. Company B must be more risky because it has to pay a higher fixed rate and a higher floating rate. Okay, so now we want to design a swap so that company A can get the floating or variable rate and company B can get a fixed rate. But for this swap to work, company B has to end up paying less than 10%, and company A has to end up paying less than LIBOR plus 1%. So in other words, we're going to make both of them better off. They're going to borrow in what they want, but at a lower rate. Okay, and that occurs because we look at where they have their comparative advantages. So the easy thing for you is, whenever you do a question, their comparative advantage is always, if I've set up the question properly, the comparative advantage will always be in the opposite of what they actually want. So company A wants the floating, well, their comparative advantage must be in the opposite, in the fixed marketplace, because they're actually going to borrow where they have their comparative advantage, which is the opposite of what they actually want to have. So you can work that out quite simply, though. The fixed interest rate difference is 3%. The floating or variable difference is 1%. Okay, so company B is charged 3% more in the fixed, but only 1% more in the floating. Okay, so that means that company A has a comparative advantage in the fixed market because it's charged 3% lower. Whereas company B has the comparative advantage in the floating because the premium difference there is only 1%. Okay, it's only a 1% difference. So in other words, if you had an economy, think back to economics, you'd tell company A, focus purely on the fixed, that 3% difference, and company B, focus purely on the floating. Because net gains, you have net gains, if you like, of 2% there, the difference between them. Okay, that's how you sort of relate this to an economics framework. So let's express this. This is how I would answer this question if I were you in an exam. Okay, so we have company A, and in fixed, they pay 7%, and in floating, they pay LIBOR plus 1%. Company B, in fixed, they pay 10%, and in floating, they pay LIBOR plus 2%. And then what you do is you just calculate the differences. So here the difference between 7 and 10% is 3%, and the difference between LIBOR plus 1% and LIBOR plus 2% is 1%. Okay, those are my differences. Then we think about what are the gains to be made. Okay, remember we want to make both parties better off. Simply, the gains to be made are just the difference between these two numbers. The difference was between 3% and 1%. So the gains to make is equal to 2%. So we've got 2% to play around with. Okay, so by getting these parties to essentially borrow in the opposite of what they want, we've got 2% interest rate improvements that we can make. Now we're going to do a really simple example here. We're going to share the benefits equally. So we're going to make each party better off by 1%. Okay, there's 2% to be gained, so one party gets 1%, the other party gets another percent. Okay, we're going to share the benefits equally. What do you think would happen in the real world? Who do you think would get most of the gains in the real world? Company A, because it has the absolute advantage. So in the real world, probably what would happen is Company A gets 80% of the gains, and Company B gets 20% of the gains. Okay, but we're going to keep it nice and simple, and then in your workshop and your tute next week, you'll see examples where you have different gains, different shares of the gains. But it's not really that much more difficult. But let's just keep it nice and simple in this question. So, gains to be made are 2%, so we're going to share the gains equally or evenly. So each party will be better off by 1%. Okay, that 2%, each party gets 1% of the 2%. So the rule is that our companies should borrow where they have their comparative advantage. And remember, their comparative advantage, the rule must always happen, is that they'll borrow, that their comparative advantage lies in the opposite of what they actually want. Okay, so it's in the opposite of what they want. So you can either look at it to figure it out, or you can go, oh, they want fixed, so their comparative advantage must be in variable or floating. So A, its comparative advantage lies in fixed. Right? So it wants floating, but it ends up borrowing in the opposite, so it's going to borrow at the fixed interest rate. Company B, its comparative advantage lies in floating. Right? It only pays 1% more here, where it pays 3% more here. We also know that it wants fixed, which means its comparative advantage must be in floating, the opposite. So it will borrow at the floating interest rate. So let's remember, Company A, Company A is going to borrow at fixed, but they actually wanted, remember, floating. They wanted a floating interest rate. Company B is going to borrow at fixed, is going to borrow at floating, but they actually wanted a fixed interest rate. For this swap to work, remember we have to make each party 1% better off. So Company A wants floating. At the moment they pay LIBOR plus 1%. So if this swap ends up working, how much should they end up paying if we make them 1% better off? What should they end up paying? Just LIBOR, right? So at the moment, they have to pay LIBOR plus 1%. We're going to make them 1% better off, so they should end up only paying LIBOR, right? We got rid of that 1% difference. Company B wants fixed. At the moment, they can borrow fixed at 10%. If we make them 1% better off, how much do they end up paying? 9%, thank you. So 10% minus 1%, they'll end up paying 9%. So see, what we've done here is we've made both parties better off. Right? So some of you might be sitting there and saying, Company A, just do your own thing. Don't worry about that high credit risk Company B. Well, no. By actually entering into this, they're going to be better off. right? Just like company B will be. So let's do the swap. The first thing you do is you draw 3 boxes, always. 3 boxes. You have company A, you have an intermediary, which might be a bank. This is the person who set up the swap, and you have company B. Now in this example, this simple example here, the bank in the middle is not charging a fee. But normally they would charge a fee. If they charged a fee, let's imagine it's 0.5%, then the total gains would have been 2% minus 0.5%, they would have been 1.5% gains. So you would have made each party 0.75% better off. Just 1.5 divided by 2. In this simple example, they're not charging a fee. Then you draw arrows going out. Okay? Because they're borrowing money, this represents their interest payments. They have to pay interest payments out. And then what you do is, remember company A, even though they want floating, they're going to borrow it fixed. Let's just do them borrowing it fixed. So they have to pay out 7% fixed. Right? That's what they've got. They've entered into an agreement to borrow it fixed and they pay 7% fixed interest. Company B, even though they want fixed, they borrow it floating. And their floating rate, remember, is LIBOR plus 2%. So on the right-hand side for company B, we have LIBOR plus 2%. Okay, my floating or variable interest rate. Okay, so those are just the rates that are quoted to them in the marketplace. So they're borrowed at the quoted spot prices in the marketplace. Then this is what I would like you to do. There's an infinite number of ways you could draw this diagram, so I'm going to force you to draw it only one way. And that is to always make sure you have this LIBOR rate being paid all the way across. What does that mean? Well, this company's paying out LIBOR plus 2%, so let's make the intermediary pay them LIBOR plus 2%. And let's make company A pay the intermediary also LIBOR plus 2%. Okay, so company B now is receiving and paying out LIBOR plus 2%, so the cash flows cancel out. Then we have to go back in the other direction. What did company B want to end up with? A fixed interest rate of 9%. So let's do that. Company B pays 9% to the intermediary. Now the intermediary is not taking a cut, so it pays that 9% straight to company A. And that's your swap. Let's see if it worked. Let's look at the cash flows for company A. So company A is paying out 7%, so let's put down negative 7%. It's receiving 9%, so let's put down plus 9%, and it's paying out LIBOR plus 2%. So negative 7 plus 9 gives me positive 2%, LIBOR plus 2, and then that extra 2% credit gives me just LIBOR. So company A is only paying LIBOR, check, as required. Company B receives, pays out LIBOR plus 2%. It receives here LIBOR plus 2%. So those two cancel out. And it pays out 9% over here. So net, it pays out the 9% as required. Okay, so we'll go over that again in a minute. But that's how you do a swap. What's the purpose of this? We've made both parties better off. Company A wanted a variable rate. The best variable rate they could get was LIBOR plus 1%. Right? By doing this swap, they only pay LIBOR, so they're 1% better off. Company B wanted a fixed interest rate. The best fixed interest rate deal they could do is 10%. By doing this swap, they're only paying out 9%, so they're 1% better off. So your steps again, you do a little table like this, fixed floating, you work out the differences on the fixed, you work out the differences on the floating, and then you just do the absolute difference of those two numbers. Okay, so the difference between 3 and 1 is 2, so you've got 2% gains to make here. We're sharing them evenly, so both parties are better off by 1%, which is why Company A, who wants the floating, LIBOR plus 1%, we take away 1%, they end up only paying LIBOR. Company B, fixed of 10%, we make them 1% better off, so they pay 9%. And they borrow in the opposite of what they actually want. So Company A wants floating, so they borrow in the opposite, they borrow in the fixed. Company B wants fixed, they borrow in the opposite, the floating. And then to do the diagram, and once you've done it a couple of times, it's always exactly the same diagram, just with different numbers that are given to you in the question. You start off with your 3 boxes, Company A, the bank in the middle, and then Company B. You make them pay out what they're borrowing in, which is the opposite of what they want. Company A wants floating, pay out the 7%, it's given to you in the question. Company B wants fixed, they borrow in the opposite, at LIBOR plus 2%, given to you in the question. You just write those down. The next step is then just to pay across that LIBOR rate you see here. So you make Company A pay to the intermediary, LIBOR plus 2%. You make the intermediary pay to Company B, LIBOR plus 2%. So that number here, just write it all the way across. Because then you're left with Company B receiving and paying out LIBOR plus 2%. They cancel out. You know they want to end up paying 9%, so you just make them pay that to the intermediary, and then the intermediary pays it across to Company A, and then lo and behold, all the cash flows work out. Okay, so this diagram will always be identical, you'll just have different numbers here. But these ones are given to you in the question, right? These are, in fact, all of these are given to you in the question, and all you have to add in is the fixed interest rate that you've worked out up there. That's all you have to do. Any questions? Yes?
So if the bank is charging 125%
yep.
interest for showing as B pays 9% to intermediary, then
Let's do that. Let's do that. Yep. Okay. So example here we have, let's imagine that the bank takes, let's say they take 0.5%. 0.5%. Okay, that means of the 2% in gains, we have 1.5% left. So each party is going to be 0.75% better off now. Okay, there was 2% gains, half went to the bank, we're left with 1.5%. Divide it by 2, each party will be better off by 0.75%. Which means Company A, who wants the floating, they'll end up with LIBOR plus 0.25%. Okay, it was LIBOR plus 1%. We're going to make them 0.75% better off, so they'll end up paying LIBOR plus 0.25%. Company B wanted fixed. It was 10%. We're going to make them better off by 0.75%. So it's going to be 9.25%. Is that okay? Then we draw our swap. A, the intermediary, and Company B. Nothing here changes. They still borrow at 7% fixed, and Company B still borrows at LIBOR plus 2% floating. Okay, so that is identical to the previous swap. So is this. We make them pay across LIBOR plus 2% all the way. So that hasn't changed from the previous question. Everyone happy with that? All those cash flows are the same. Borrowing at the same rates, pay across the LIBOR plus 2%. So company B is receiving LIBOR plus 2% and paying out LIBOR plus 2%. Company B, this time, rather than paying 9% interest rate, they're going to pay, that's a 5, 9.25%. The intermediary takes a 0.5% cut, so 8.75% now goes across. So 9.25 went in, they take the 0.5% cut, and they pay out 8.75% to company A. Is everyone okay with that? Okay, so no different to before. We cancelled out all the LIBOR rates for company B. They had to lock in a 9.25, so we paid that across. The intermediary takes their 0.5% cut, and we end up with 8.75%. So company B, its total cash flows are a negative LIBOR plus 2%, a positive LIBOR plus 2%, and negative 9.25%. Those cancel out. They end up with 9.25%, right, as required. Company A has a negative LIBOR plus 2%. It pays out 7%, and it receives 8.75%. So if you look at these, it's better off by, well, it's got a positive cash flow of 1.75%. So 2% minus 1.75% gives me LIBOR plus 0.25, right, as required. Okay, so not really that much more difficult. The only thing that changes here is these numbers here aren't the same because the intermediary is taking a 0.5% cut. But the bottom cash flows, all the same. Now 9.25 goes in, it keeps 0.5, 8.75 comes out. And both parties are better off now by 0.75%. Did that answer your question?
Why the cost of companies comes from the outline rather than the bottom?
Why, sorry? Why?
Why the cost of companies comes from the outcome flow down is not rather than the bottom?
The money the intermediary takes? Yeah. So I'm forcing you to do that. Right? So you can do it your way, right? But when a quiz or an exam gets marked, right? So what you could do, right? You could do at the bottom and then just have 9.25 going across, but there's a second solution to mark. You could have LIBOR plus 0.099 and then a different number at the top. You could have an infinite number of solutions, right? Depending on where you take the cut from. So when I give you a quiz or an exam, I will say pay the LIBOR rate all the way across. And there's just one solution. And it's what I've taught you in the lecture. But you're right, you can do it your way, but I just want to see one solution to maximize your chance of getting full marks. Okay? But you're right, you could do it what you're saying. Yes?
So the one solution is to always take the cut from the top.
That's correct. So the one solution is this LIBOR rate that goes out, always pay that exact same number all the way across. So if LIBOR plus 2% is going out, you're going to see LIBOR plus 2% here, LIBOR plus 2% here, which means the cut comes out of the fixed component, right? Out of the fixed component. Okay, how else could this differ? This could be an investment. Okay, an investment rather than a loan, in which case you want the highest possible interest rate, right? So you want to add interest. And the cash flow, and you'll see that in your workshop and quiz, and then the cash flows, rather than going out, will come in, right? So you'd see interest rates coming in, interest rates coming in. But this time, you'd also still have the LIBOR rate going all the way across. So if LIBOR plus 2% is coming in, it'll be paid LIBOR plus 2% all the way across. Okay, so it makes it really simple. Just remember that LIBOR rate quoted to you in the question, pay it all the way across, and then play around with the fixed rate component. And then you'll see we can share the gains. Well, sorry, we can divide the gains up differently. So we could have given company A 1.25% and company B only 0.25%, and the bank keeps 0.5%. Doesn't matter, just the fixed number you write across will be different. They'd write across 9.75% because they're going to be 0.25% better off. Then the bank takes its 0.5% cut, and then 9.25% gets thrown across. Okay? Either way, it works out. Once you've done these 2 or 3 times, they're quite straightforward. Past mid-semester exams, 90% of the time have a swap question. So I haven't set you a mid-semester exam, but I'd imagine this would be a good topic to know, right, for your mid-semester exam. And it's not going to be nice and easy, right? We're going to be sharing the gains differently, right? The bank will take a cut, but realistically, it's not that much more difficult, right? You'll see those questions, those practice questions. Okay, so that's just what we have here. I think my overheads will make a little bit clearer, but you may disagree, so you can look at these slides here. And what we've done is, thank you, we've made both parties better off. And we've also swapped, if you like, their exposure. They've gone from fixed to floating or floating to fixed. And you can do the same, as I said, with an investment. And again, you make both parties better off. So if this, for example, had been investing money, company B would have the absolute advantage, right? It earns higher interest, 3% higher on fixed and 1% higher on floating. But in this case, it'd be the opposite of what they actually want. Because they earn 3% more in fixed, right, they would actually have the comparative advantage in fixed. Okay, so this swap wouldn't work if it was an investment. Okay, it wouldn't work. So I promise you, if I give you a question in an exam, it will work, right? It will work. But if this were an investment, this swap wouldn't work. We'd have to end up with different numbers. Okay, so the final thing we want to look at today, and this is what your quiz is on next week, right? So this is what your quiz is on next week, is the valuation of interest rate swaps. So how do I value this swap? So a bit like a forward or futures contract, when you first enter into a swap, it has a value of 0. Okay, so when we set this swap up initially, both parties shared the gains. The value of the swap is 0. As you go through time, though, the swap to one party will become positive and to the other party will become negative, such that they net out at 0. The reason for that is that that floating interest rate will change over time. So if you're exposed to the floating rate and the interest rate goes up, the swap will now have a negative value to you and a positive value for the other party. So the question is, how do we work that out? And it's pretty simple. You just find the value of the relevant bonds, the value of the fixed rate bond and the value of the floating rate bond. Okay, we know how to find the value of bonds, right? We take the coupons, we discount them back to time 0. We take the face value, we discount it back to time 0. But there's a problem. That's with a fixed rate bond. It's fixed, so the coupons are going to be fixed. With a floating rate bond, the coupons change as the interest rate changes. And you only know the value of the next coupon. What do I mean by that? I mean, if today a coupon gets paid, so you receive your coupon today, you'll be told by the company, this is the value of your next coupon. But you only get told the value of the next coupon. You don't know the value of all the future coupons. So the great thing for you guys is when you do these calculations, you get to ignore all those future coupons. So when you value a floating rate bond, you look at the next coupon date, you discount the value of that coupon back at that date, and you also discount back the face value of the bond at that same date. So if the next coupon's paid in 4 months, even though there might be 20 coupons to go, you just discount back that coupon 4 months, and you discount back the face value 4 months as well. Okay, so that is the convention for valuing a floating rate bond. And it's actually really easy. You take the value of the next coupon, you add on the face value, and you discount it back to time 0. For the fixed rate bond, you've still got to consider all the cash flows. And the value of the swap is always going to be the value of the bond that you receive minus the value of the bond that you pay out. So what does that mean? That means if you're receiving fixed interest rates, fixed cash flow, fixed bond cash flows, and you're paying out floating, then it'll be the value of the fixed minus the value of the floating. If you receive floating and pay out fixed, then it's the value of the floating minus the value of the fixed. And that makes sense because two parties in the swap, one's receiving the floating and paying out the fixed, the other's receiving the fixed and paying out the floating. So to one party it'll be positive, to the other party it'll be negative by the same amount. Okay, but the question will always be clear. It will say you're receiving fixed and paying out floating. It'll be very clear, I promise you. I'm not going to try and trick you. Okay, so let's look at an example. Given the following information, find the value of the interest rate swap. So suppose that a financial institution has agreed to pay 6-month LIBOR, okay, and receive fixed 8% per annum with semi-annual compounding on a notional principal of $100 million. So this is paying out floating, receiving fixed. So the value of the swap will be the value of the fixed rate bond minus the value of the floating rate bond. They're receiving fixed, so it's the value of the fixed minus the value of the floating. The swap has a remaining life of 1.25 years. The LIBOR, the LIBOR rates with continuous compounding for 3, 9, and 15-month maturities are 10, 10.5, and 11%. Okay, so interest rates aren't constant. And the 6-month LIBOR rate at the last payment date was 10.2% with semi-annual compounding. So that 6-month LIBOR rate at the last payment date of 10.2%, that is your coupon rate. So the next coupon you receive will be 10.2%. To work out the value of the coupon, you'll divide it by 2 and multiply it by the $100 million face value of the bond. When you value that floating rate bond, you're going to look at the next coupon date. You're going to take back that coupon and the face value. So who remembers from Foundations of Finance uneven bonds? Do you remember? You should remember uneven bonds, right? That's what you have here. So you draw a timeline. So we're told that the swap has 1.25 years remaining. So if we draw a timeline, 1.25 years. Okay, so we're going to draw the fixed rate bond first of all. What do we know we receive at the end of the life of a bond? We receive the face value and we also receive the final coupon. How often are coupons paid? So we go back in time. So at 3/4 of a year from now, you'll receive, what will you receive? I'm getting worried. Coupon, thank you. 6 months earlier, you receive a coupon. So this is an uneven bond because you don't receive the first coupon 6 months from now, you get it 3 months from now. That's because this swap's been in place for a period of time. Right? This might have been a 5-year bonds. Right? And we're now 1 3/4 the way through its life and we're valuing the bond. So it's still got 1.25 years to go. But when you draw a timeline, you see the first coupons in 3 months, 9 months, 15 months. Which makes sense because remember in the question you were given the interest rates for 3, for 3 months, 9 months, and 15 months. So that's my fixed bond, so that's what I've got to do. Simple. For my floating rate bond, it's even easier. We don't know what the coupons are on those days, right? All we know for sure is that the coupon at the next payment date, right, is 10.2%, and that's 3 months from now. So we ignore that. We ignore that. It's nice. And instead, we value the coupon at face value. We bring it back at time period or quarter. So we bring it back 3 months. So you all covered uneven bonds in Foundations of Finance. So all you need to do really is draw a timeline. And because we don't have present value annuity formulas in this course, right, you don't have to worry about doing variations, just discount them back. So for the fixed rate bond, the coupon rate is 8%. We divide it by 2 because they're paid twice a year. We multiply it by the face value of $100 million. You receive coupons of $4 million every 6 months. The first coupon you receive is 3 months from today, right? You're halfway through a coupon period. So you take that $4 million, you bring it back a quarter of a year at the 3-month rate of 10%. In 9 months, you get the next coupon, you bring it back 9 months at 10.5%, and at the end of the life, in 1.25 years, you get the $4 million coupon, the face value of $100 million, you bring it back at 11%, the 1.25, the 15-month rate, to give you $98.238 million. The value of the floating rate bond. So you're told the value of the next coupon rate will be 10.2%. So we take the 10.2%, we divide it by 2, we multiply it by the face value of $100 million to give me $5.1 million. And then we ignore all the future coupons. We just value the bond at the next coupon date, taking that coupon and the face value of the bond at that date. Even though it's got another year to go, we ignore it. That is the convention for valuing floating rate bonds. So we take the face value of $100 million, we add on the $5.1 million coupon, we bring it back 3 months at 10%, the 3-month rate, to give me $102.505 million. That's the value of the floating rate bond. So in this question, because I'm receiving fixed and paying out floating, the value of the bond to me, or the swap, sorry, the value of the swap to me is negative $4.267 million. For the person who is receiving floating and paying fixed, the value of the bond to them will be positive $4.267 million. They net out to be zero. One party's better off by $4.267 million, the other party is worse off by $4.267 million. So all you have to do in your quiz next week is value 2 bonds. Okay, value 2 bonds. One of them is what you're used to, present value of all of the coupons, discount back the face value. The other one's even easier. You ignore all the future coupons and you just bring back, for the floating rate bond, the next coupon and the face value at that coupon date. Okay, that's all you have to do. And make sure you match the interest rates to the time periods, okay, if there are differential interest rates. So credit risk. When you first enter into a swap, there's kind of no credit risk because the value of the bond is zero. Okay, but as you go through time, the swap does accrue value to it, right? In this case, one party's better off by $4 million, the other party's worse off by $4 million. You have credit risk, you're exposed to credit risk if the value of the swap is positive to you. Right? In this example, one party, we said, is better off by $4.267 million. Well, that's a risk they're exposed to. If the other party doesn't fulfill the terms of the contract, they will lose that value. They will lose that $4.267 million. So they're exposed to that risk there. Okay, they're exposed to the credit risk of another party. And they have to go and sue them to try and get back the money. Okay, which isn't a particularly efficient sort of method to go by. Okay, are there any questions on today's lecture? Okay, so just as a reminder, this week you have a quiz, right? And that quiz is on finding the value of forward contracts. Next week's quiz is on finding the value of swaps. Okay, I would, wait, still got some time. I would encourage you to come to the workshop on Thursday. You're going to see two different types of swaps being explained to you. You're going to see a swap where it's an investment, so the opposite of what we've done today. And you're also going to see a currency swap, okay, where you swap in different currencies. So rather than, thank you. So rather than swapping fixed and floating, you're going to be swapping pounds for dollars or yen for euros. Okay, swapping in different currencies. And next week's lecture is where we finish with forwards and futures contracts. Okay, and we move on to options contracts. And so it's everyone's least favorite part of this course, right? Because we do option trading strategies and everyone freaks out. And they ask me, do I need to know how to draw these? Because there's lots of things to draw. I will answer that question for you next week, okay? But I actually find it one of the best parts of the course, right? I think it's kind of fun because you can do some neat things with these option trading strategies, right, that you haven't thought of before. Okay, if you've got any questions, please come down and see me. Thank you.